Okay, good morning, and thank you all for joining me today and the Richards-Wilcox Conveyor team. This morning, we are introducing to you our Manufacturing Pro Series. The title of today is Evolution: How to Optimize Manufacturing Efficiency. I am Rita Hockey. I am with Choose DuPage. So if you have joined us for other webinars, you know that I begin the webinar with a little bit about who Choose DuPage is. All right, Choose DuPage can be summed up in three main points. We are all about business attraction, business retention, and business growth for DuPage County. We have two programs that I want to highlight for our businesses, and that is our Connect DuPage program. That one is about encouraging and fostering business-to-business connections. How we do that on our website under Connect DuPage, we do have a supplier portal. Please create a free profile. And then we have just recently launched, you can search that database to find vendors or suppliers so you can buy local. So I would encourage all of you to utilize that. We also do educational events. Our other newest initiative is Sustainable DuPage, and that is about promoting positive environmental impacts. How do we do that? We are doing some green business assessments. So if anybody is interested, please contact me. Happy to talk to you about that. And then we do have, from last year's assessments, we launched a green business checklist. And so any company, maybe you're not interested in having the customized assessment, but you'd like to get started on your own in some sustainability actions, please go and download our green business checklist. It does cover all the areas: transportation, procurement, water, energy. And then again, we are doing educational events under that as well. So now that I've gotten my 2 seconds in, I am going to turn it over to the Richards-Wilcox team to present to you this morning.
Well, good morning. I'm Bob McMurtry. I'm the president of Richards-Wilcox. With me to my left, your right, is Matt Chorsky. He's a senior conveyor systems sales manager, and Bob Kanega, who is the Richards-Wilcox conveyor division manager. A little bit about me. I've got over 25 years of advanced manufacturing leadership. I've worked in high volume, just-in-time supply chains in automotive, appliance, medical, agriculture. I've also worked in customized low volume supply as well. So I've run the full gamut of manufacturing in plastics, chemicals, steel, a variety of different industry and applications. Matt Chorsky has more than 35 years of designing, configuring, and implementing material handling conveyor systems, both for manufacturing, distribution, and working with customers to optimize their facilities. Bob Kanega is our most recent addition to the conveyor group as the conveyor division manager. Some of the highlights of his experience is over a quarter century of operational experience in all aspects of custom designed machinery, from the sales side to the sign-off side. So he's worked with conveyor installation and servicing to optimize productivity, and he's also had customer-facing and service experience and a track record of improving quality, safety, and productivity. So with that, let's launch into the presentation. Hopefully we're going to share our screen here. Let me know if you can see the screen, Rita.
It's perfect.
Okay, next slide, please. So Richards-Wilcox Conveyor, go ahead, next slide. So I want to talk a little bit about who Richards-Wilcox is. So we were founded in 1880 in Aurora, Illinois. It's a privately held manufacturer that's been manufacturing high quality American-made products in the same location for 144 years. So we've continuously manufactured in this same facility since 1880. We design and manufacture products across three distinct brands. So the first brand is our RW Hardware brand. This is the origin of the company dating back to 1880, and it's specialty door hardware for both sliding and swinging doors, so hinges and sliding tracks. And we sell that hardware, specialty hardware, to a variety of industries, but one of the notable industries is zoos and aquariums. 2 years ago, we were design responsible for all the animal enclosures for SeaWorld, built in Abu Dhabi, the first SeaWorld built in 30 years, first one outside the country. And we designed and manufactured animal enclosures for 100,000 marine mammals. But we designed everything from, and manufacture here in Aurora, everything from do-it-yourself sliding door projects, barn hardware, to zoos and aquariums and equipment. The second brand that we manufacture here is Aurora Storage Systems. And Aurora Storage provides storage solutions from priceless vaccines to museum collections to archival corporate documents. We did McDonald's corporate archives. We do universities, libraries. So really the storage of anything. And that's our Aurora Storage brand. Next slide, please. And that brings us to our third brand, which is the Richards-Wilcox Conveyor brand. And evolving out of the hardware brand, where we invented the enclosed box track, what you think of today as barn door hardware, we, in the early 1900s, we invented what we call the enclosed track material handling conveyor. So we took that box track that we were doing for barns, and we realized that if we put those together and hung them in the ceiling of a factory, we could automate material handling. So we invented in 1920 the enclosed track manual conveyor. In 38, we patented the powered chain zigzag conveyor. In the early days, they were manual push conveyors. This picture on the right shows you bananas being distributed in a factory in the early 1900s. We are privately owned. We have approximately 150 employees, and we have a 365,000 square foot factory. Next slide, please. So I've already talked about who we are, so we've covered that. Go on. So this is kind of what we're going to talk about today: the importance of automation in material handling, in manufacturing and distribution, the challenges that are presented in creating a better, smart factory. We're going to talk a lot about the basics of overhead conveyors, and then the integration of those overhead conveyors to other kinds of automation, which is really the key. And then we're going to sum up with some best practices in overhead material handling, and then we'll have a Q&A session. Next slide. So why automate, right? A recent survey showed that in warehouse and manufacturing, people are automating their factories. 73% say they are seeking automation because they can't find enough labor, something I'm sure every one of you and we have experienced. 70% say that the labor they can find is unreliable. In other words, they don't show up consistently to work. 52% of respondents said they can't find the labor that they need with sufficient skills to run a factory or a distribution center. And then 20% of respondents just said labor rates are too high to fully staff their facilities. So automation addresses the labor side of the demand. Next slide. So the importance of automation. You know, what is factory automation? I think most manufacturers are already familiar with the benefits of automation. Doesn't mean that they've done it, but we're all talking about it, and we've been talking about automation for a couple of decades. But factory automation is the implementation of technology and systems that automate a manufacturing process with the ultimate goal of increasing productivity and reducing costs. So what is, the level of automation can go from anything from a single operation where you automate a repetitive process to an end-to-end factory automation where you can eliminate all the human interaction throughout that factory. And we're going to show you some examples of that today. Automation can be implemented at any point in the process, from material handling to, incoming material to assembly to finishing to packing, palletizing, and ultimately to shipping. And the level of automation is going to vary on the complexity of your manufacturing process, your budget, and a range of other criteria. So, most factories, most industries nowadays have some level of automation. So again, it starts with the most basic, which is single manual minimal automation, to the next step would be a single process where you have a repeatable process and you're implementing that, to the automation of full production assembly lines, which is combining material transfer and dedicated workstations to fulfill a particular process, to the fully automated end-to-end process where you envision a lights-out operation that can run 24/7, 365, right? That's the ultimate solution that goes, to the full extent, right? That's a really challenging process, but people are doing that. So what are the benefits of factory automation? Improved productivity, right? If you can go end to end and you can, or even a singular process where you can run 24/7, 365, you increase your productivity, you increase your CapEx utilization. And so that's really where you can see the most improvement in productivity and the highest degree of cost reduction. You also, another benefit is improved quality by reducing human error. So the more you can take humans out, or the more you can error-proof the process, the better your quality is going to be. Along with that is improved consistency, right? So we strive for repeatable and reproducible processes that either error-proof or mistake-proof the process to eliminate human error, and automation helps with that. And then flowing from that improved quality and consistency is the reduction of waste, and therefore the elimination of wasted cost, right? And then finally, it really is about worker safety, and automating processes can eliminate risk in the factory. They can also add to it. We'll talk a little bit about that and the role of digital simulations in trying to reduce and mitigate risk in the factory. But ultimately, the more automation you can implement, the safer the work environment. And ultimately, the main driver is cost savings. So really, automation is intended to increase productivity and efficiency and thereby reduce your costs. So what are the costs of implementation, right? The flip side of all those benefits I just talked about is the cost of implementing automation. So the initial outlay of capital is usually high, both in equipment and in integration of that equipment. It also tends to be very specialized process equipment, which drives the cost of that. So one of the keys in design, and one of the things that we focus on, is future-proofing your design and designing. I think you went back one. There we one more. One more. There you go. Okay. So you want to future-proof that design so that the future innovation in your product or your process doesn't require a complete retooling of automation. There's also a cost associated with upskilling your operators. So finding experienced automation technicians or training your existing employees for those roles has a cost associated with it. So one way to minimize cost is to employ an experienced automation engineer or partner to help design systems using existing technologies and containing costs. All right, next slide, please. So some of the challenges, right? I just talked about the high cost and unrealistic return on investment expectations. So really understanding the challenges of automation and how to overcome them improve the potential for success of automation projects. Failure to face the challenges likely will result in a poor implementation and higher costs. So since automation comes with a lot of upfront costs, you need to be realistic about what the expectations of your return on investments are. Experts suggest that when estimating the cost of automation projects, the true costs of automation are about 3 times the cost of the equipment acquisition. So a lot of times companies look at the cost of a conveyor system, cost of a robot, cost of an automated process, and think that's the cost. You really need to estimate about 3 times that between installation, implementation, debugging, and upskilling your labor force. And again, realistic expectations, we talk about eliminating all the labor, but history shows that you really only reduce labor by about 25% by automating the workflow. So you can't eliminate that labor cost entirely. So the first step in building a better factory is really understanding and setting realistic return on investments. Other ways to manage that cost include really focusing on need-based automation, not automation as a solution in general. Really, it's focusing on where you are going to get the best benefit, which means a successful implementation that drives to a particular need that solves a problem. Smaller companies may also look at robotic as a service, which is an opportunity out there to reduce those upfront costs. And a little bit of statistics, there are about 292,000 factories in the US. 91% of those factories have less than 100 employees. So the majority of manufacturing is small business manufacturing, right? So when small businesses look at automation, we really have to focus on budgets. Richards-Wilcox manufactures overhead conveyors, so we design and sell those, but we're a manufacturer at heart. As I talked about, we have 3 brands. Everything's manufactured in the same factory here in Aurora. So first and foremost, we're a manufacturer. So we live and breathe automation and robotics and conveyors, just like you guys are doing. Only 8% of the factories have 100 to 1,000 employees, and only 0.2% of factories have over 1,000 employees. So really, the heart of automation is small business, right? Other challenges, again, I talked about automation and worker safety. So one of the solutions that we offer is full digital simulations. And you really have to understand the challenges that automation present in the factory and how to address those. Another challenge is the integration and scalability, right? You need a solution that's going to be flexible and can grow and evolve with your process. So really consider changeovers and setup times and infrastructure needs so that you're not too disruptive. And design flexibility into the system so that you can anticipate not only your current problem need, but also future needs. And then again, I touched on the staffing, right? You need to plan on upscaling your existing workforce to be automation experts. The studies say that there'll be 2 to 3 million vacant positions in automation and factory by 2030. So the tech sector is really looking at a severe labor shortage. So you really need to plan on developing tech experts inside your facility, not finding them on the street. And then, of course, cybersecurity is a big concern everybody has, and there's a whole other webinar that could be had on cybersecurity. Next slide, please. So I want to talk a little bit about, I'm going to actually turn it over to Matt Chorsky, our Senior Conveyor Systems Sales Manager, and he's going to touch on some of our conveyor products and how they're used and where they're used.
All right. I want to thank you all for joining us today and taking time out of your busy day. We're going to move pretty quickly through some of these slides just to make sure we have enough time at the end. What you're seeing here is a slide of our trade names, starting with the most basic manual system. We have a trade name called Safe Rail. Zigzag is when we added the power track to the rail. We've also can invert the track for clean room applications. We'll add side-by-side power and free. We call that twin track. Overway is a power and free conveyor. The picture on the left is a picture of overway. heavier duty power and free. And then the inverted monocart, inverted overway are floor mounted inverted style conveyors. And we'll be going quickly through each one of these.
And Matt, real quick, I think that these have evolved because we've been in business for over 100 years. And we have found that one solution is not always applicable to the customer. So we can design and find the best way to help the customer, correct?
Correct. Basically from top to down to the bottom is the evolution of conveyors since the early 1900s. Next slide. Okay, so conveyor applications that we run into here are many different types. Almost anything that can be hung is an application, but in general, finishing or painting, coating type lines, inline assembly, distribution, order fulfillment, basically empty box, empty totes and distribution centers. Robotic interface is very common for us. Long loads, extrusion type handling or long loads are very common on applications we see here. And work whip. Oftentimes we need to accumulate, use the upper levels of a factory up and out of the way overhead for storage, and then retrieving them back down when you need those parts. Again, large parts are also good applications for an overhead style conveyor.
Yeah, and I think one of the things Matt touched on, I just want to emphasize, and that is we keep saying overhead, and we do a lot of overhead conveyors. But when we talk about inverted, all of these conveyor lines can be inverted and floor mounted. And so it's not just overhead, it's both overhead and floor mounted.
Correct.
The beauty of the overhead conveyor is it takes full advantage of all of your vertical space. So you get a lot of space in your factory for part storage, part movement, that you can't do if you're using roller conveyor or lift trucks or automated conveyances that operate on the floor. But we can do both overhead and floor mounted.
Right, and that picture on the left is a boat, a engine for a marine boat,
Right, so-
Malibu boats.
Right, so that's a V8 engine being, conveyed across assembly area to ultimately end up in a boat.
Yep. Next slide. Okay, so the first trade name and the most basic is Safe Rail. I'm not going to go through all the bullet points here, but they're manual push systems. And this just shows an application of where an operator open and closes a door after the parts are painted to fill, for instance, a cure oven, close the door, and then after a certain amount of time, they open the doors and bring the finished cured parts out and allow cured parts back in.
And again, these could be manual push systems for assembly, for any number of things, not just finishing and painting.
Exactly. Next. And then we added the power, which is pretty much the most common application we see is a monorail powered enclosed track where the entire line moves together all at the same time. The picture on the left is showing a bread making machine. The picture on the right is a 2-level tote system where there was a kitting process and they were feeding the assembly lines operators to finish their parts that they were making online.
Yeah, and these kinds of systems, if you're in distribution, right? We've done these at UPS, or imagine any kind of a carrier distribution facility where you're picking orders and combining orders to send them to trucking. It could be retail distribution centers that are picking orders and sending them to the retail outlets. It could be truck bays going, cross dock, picking and storing. Imagine Amazon, UPS, Hobby Lobby, Home Depot, any of those kinds of applications, as well as the assembly process on the left.
Yeah, we do have a picture, I believe, coming up of that. So you can go to the next slide. Yeah, it is on the next slide. So up above is empty totes that were delivered for a Hallmark card facility, where the operators would pick an empty tote, fill their order, and then it would be handled on the belt and roller floor system down below. Again, just more pictures of a standard powered monorail, and our trade name that we use is Zigzag.
See, when I look at that, I think of all the savings they got because they do not have to expand their building. They can use everything above them and the footprint remains the same. Big cost savings.
Yes. Next. Okay, inverted zigzag. Now, we've taken that zigzag. It's a little hard to see in the picture, but we've inverted it so that the chain slot and the hanger is now up on top of the track and then down below, so that there's no debris, no chance of oil drip.
Going the wrong way.
So it's more common when for finishing lines or medical applications where they have to be extremely clean, and then you can still handle the parts on there and not have any potential debris or oil coming out of the track. So next slide. Oh, and there's an application there, I'm sorry, with a robot. Now, when we get past the monorail type conveyor, we get into what's called power and free, and a lot of people out there are unfamiliar with power and free. But what this is now is adding a free track and a power track, which will now allow you to divert to multiple positions, put a stop in at any location, accumulate parts. So now this opens up the door to a lot of different applications for an end-to-end style system where less human interface can be in as part of the project.
So if you think about it, the chain that's driving in the zigzag system of the previous example, that chain is continuously running. So when you have a zigzag, your material that's moving is continually moving with the chain. The addition of the twin track power and free, as Matt just said, that chain continues to drive, but we're able to delatch and disconnect the carrier, which holds the product, and accumulate that or slow it down, stop it. And that all of a sudden has created a great deal of flexibility in how you can use the conveyor system to move your material and process it through the factory.
Yeah, many applications. The picture on the right just is an example of BMW carpets, where they automatically diverted the color carpets down each lane, and then they would automatically merge them to the color sequence they need at the production as they're producing the car. Next slide. And a couple more pictures with twin track. The picture on the left was for handling automatic door arms, that closures, small parts, and that same job is on the right, just showing the parts going through a wash treatment before they apply the paint.
And Matt told me this morning, this facility is in Chicago and they wanted as close to Bears colors as we could give them. So blue and orange.
Yeah. Next. Okay, twin track. Again, we won't go through all these bullet points. It's what we want to call a light or medium style or medium duty conveyor. Many applications are 300 pounds and less, and that's kind of where this fits in. This picture on the right is showing the final unload area, where we diverted into 5 different unload stations from up above high, utilizing the upper level of their factory, bringing them down to the operators so they could unload light parts onto pallets for shipment. Next slide. And then overweight. So when we go to overweight, the same applications or similar applications to twin track, except now we can get up to about 3,000 pounds. We're using structural channel, C channels underneath and powering it with our same chain and as we use for zigzag. The picture on the left is an assembly application for a freezer. And the picture in the middle is up to 40-foot long pallet rack frame. So it's a long weldment that is transferred sideways and through a paint line. And then the picture on the right was also a paint line for steel bumper parts for trucks. Next slide. Again, this is a picture of an overweigh. It says up to 2,000 pounds. Typically, we stop at 2,000, but we have done 3,000 pound applications when the application is right and it's level. There's no inclines. This is showing some long extrusions that were painted, diverting to 2 different color paint booths. So pretty much any application we're willing to look at.
The thing about 3,000 pounds, the safety issue of trying to move that through a factory on the ground, that I'd be nervous all the time going through that. So this is a great example of safety.
Next slide. We're moving too fast. Okay, inverted. Now, we use some of the same components when we invert, same chain and pusher dogs. But now when you're inverted, we have 2 different styles of trade names. One's called monocart, and that's more of our medium duty, up to 300 pounds. And now you're able to, you know, in a finishing line or an assembly line, invert and have the conveyor underneath. Now this provides some obstacles on the floor for operators and truck movement and everything else, but it allows complete clean, no conveyor overhead for any oil drip, any debris, a true clean line style conveyor. And then we also have a product line that's called inverted overweight power and free. And this now gets up to about 750 pounds, I believe, per carrier. The picture on the right, now, when we have power and free, keep in mind, we can add a stop and accumulate. We can single them out, interface with robots. And that picture on the right is showing accumulated empty carriers before we put the load on. And then the picture in the middle was for a bumper line, plastic bumper paint line, and same with the one on the left. And on the one on the left, you can see we can go into the floor, under the floor, and allow operators to walk over those sections and bring the load down for an ergonomic unload and load height.
One of the things we're going to talk about in a minute is kind of industry 4.0 data acquisition and information. And on that picture on the right-hand side, you can see a couple of the sensors. So one of the things we're able to do is we're able to monitor part present and rotation and RFID identification. There's all kinds of data, real-time data acquisition that we're capable of providing to your MES system or your ERP system or however you're managing the workflow in the factory. So I just wanted to point out those sensors because this is kind of a good picture.
And they're all, they're not hardwired anymore. They're all quick disconnect. So that if you have a sensor that goes bad for maintenance, you can unplug and replug another one in without, rewiring the whole thing. Next slide. Another picture of our inverted power and free, again, without the load on, showing an accumulation area and a little small picture there entering an enclosure, either a paint booth or an oven. That was for a spoiler, a paint line for a plastic spoiler for a GM car. Then the next slide. Rotation. So we have a little video clip showing a rotation application.
Need to kill the volume on that.
There we go. So this is an application where we automatically rotate while the conveyor line is moving slowly. We have all types of different rotation applications at a stop or while it's moving in line. This one happened to be without stopping at a slow speed. The robot is able to paint one side of the load. We rotate, and now it's can complete the paint of the backside. Again, this was an automotive parts. I believe they were door handles, if I'm not mistaken.
Yeah, one of the big challenges with factory automation is finding that turnkey solution provider that can integrate the robotics and the MES systems and the Industry 4.0 data interface. And this is a good example of that. So as that part's rotating, the robot needs to know when the part is present. The robot needs to know that the part is fully rotated so that it can then go in and execute a pre-programmed routine. Because that robot doesn't, needs to know where the part is and when it's ready to execute. So we're able to provide that.
Right, and if they change parts, we'll be able to communicate with the robot that it's a different part, and then they can use a different program.
Yeah, that's a good point.
Yeah.
Frequently, you're not making the same part, painting the same part all the time. So the carrier can have a barcode or an RFID and communicate with the robot to say, now I'm painting Mustang door parts, but the next carrier's got, I don't know, Chevy Traverse or a different part, right? And so that gives you great flexibility in the manufacturing process. Let's go on.
Yeah.
Well,
This is the fun part,
hang on,
not this, the next part.
just hit pause. Yeah, and then go back. So just a process check here. Rita, can you see the presentation?
I can.
She might be.
Yeah. Okay.
Good. So as we're saying, we already talked about, it's our solution, our platform is process and equipment agnostic. In other words, our equipment plays nice with different robot manufacturers, different equipment that's out there. We can integrate with all of it. But from an industrial or safety or finance perspective, they want to make sure that, hey, am I getting the return on investment? And RWC puts together simulations so we can validate all the claims that we're making with this. And this is a great demonstration that Matt put together a while ago for one of our customers.
And I think when, what Bob just said, when you're looking at return on investment and you're trying to make sure you're going to get what you want to look at throughput, right? You're looking at takt times, you're looking at throughput from process to process, and digital simulation before you put one piece of equipment into the factory gives you the ability to simulate that process flow, that takt time at each step, and maximize your productivity. And so this is a tool that we offer.
Yeah, this can be done during the engineering phase before the installation's installed, and potentially could find some issues where there may be modifications that can be done that you can catch when you run the simulation.
Let's take a look at that simulation, if you can pull that up for us.
So we have an example of a simulation, a project that was engineered and installed in Iowa. I think we might have to reboot it.
Just hit the,
So
he's trying to hit the play button, but he can't see it.
yeah. We'll get it.
It's going to be worth it, trust me.
Now, yep. There.
Right, so this is a good example of what we've been talked about earlier, which is an end-to-end, no human interface of manufacturing a rubber or polyethylene. I'm not sure the exact tire. It's a tire for a forklift. And there's 3 systems, 2 overhead systems with an inverted power and free overlay, power and free system underneath. So the first system closest to us is an overhead system with the ring molds, and there's different types of ring molds. So every carrier in the system has a smart eye tag, which we know what's on there, what's been loaded onto each carrier. The robots will pull the correct ring off of the first line, place them on a conveyor that warms the rings up overhead above the fill line. So underneath the second conveyor, the robot reaches up, pulls off the rings, places them down below on a warm mold. And the robots on the left and the pour machines, there's two of them there turning off red and green, automatically match the ring with the mold. And then they're filled with the solution, which is then conveyed into a cure. I believe it's somewhere around 280 degrees, where the solution is then hardened. And then for the amount of time that's required, and then the two robots on the left are unloading the finished tire, cleaning the molds and rings, and sending them back in and to be warmed up again.
So this is a good example of again, the overhead conveyor taking full advantage of the vertical space, the floor mounted conveyor integrated with multiple different levels of automated equipment. And as Matt said, a true end-to-end solution where they can run 24/7, 365 unattended. Obviously, there's maintenance and preventive maintenance involved with that. But this is a solution that we did over in Iowa, and again, making tires for lift trucks. And it's a completely integrated solution, all engineered by Richards-Wilcox here. Anything else on the simulation, Matt?
No, the customer's been very happy with this particular
Next slide.
system.
So just want to touch on a little bit about the integration. Everything we've talked about is our overhead and floor mounted conveyors, but really today, the key is integrating it with other technology. So, both with the rising popularity of e-commerce and the need for faster shipping, faster delivery, the challenges of labor and labor shortages and skilled laborers really is forcing the integration of what I'll call peripheral robotic solutions to automated material handling solutions. And there's all kinds of different potential there, right? Everything from dedicated robotic integrations. We've looked at several of those. What this picture on the right shows is a cobot type application where the guy in the background is actually teaching a paint gun how to paint. It doesn't require advanced programming and a huge ordeal. The guy just goes out there and the very first part he paints and the robot remembers it, the cobot remembers it, and then he can walk away and they can continue to operate robotically. In the warehouse, automated storage and retrieval systems, the AS/RS type systems for part retrieval. We can integrate our conveyors where a AS/RS system pulls a part off the shelf, puts it on a conveyor, takes it to a packing station, and then we pack it. Articulating linear reciprocating robots, articulated arm robots, automated guided vehicles or autonomous mobile robots. All of these are innovations in the warehouse space that are gaining popularity and implementation, and really to reduce time and increase productivity, reduce labor. We can integrate our systems with all of these kinds of automations.
And on top of that, Bob, while they may not have that there right now, and we don't do it here ourselves, we do have partners for this
That's
as well.
Yep, that's right.
So we do have the experience.
So we can't give you that one stop. Next slide, file. I'm watching the clock here. We're getting close to ending time. So,
Yeah.
again, integration of picking and sorting type applications, loading and unloading, palletizing, depalletizing, that end-to-end solution Matt just showed the simulation of, really envisions all of these, right? Picking the right mold, putting them in the right location, loading them onto the process, unloading the tires and palletizing those. We also showed examples of assembly, painting, finishing, and you can automate delivery. We actually have a system, this came up in COVID, but we have a conveyor system at the Houston Food Bank, the largest food bank in the country. And they prepare meals in the kitchen and they send them through our conveyor system out to the front of the house for delivery. Next slide, please. So some of the best practices that we want you to take away, right? Select an experienced partner. Make sure that you have a full solution integrator, somebody that can really understand your process and the integration of, as Bob just said, the integration of other peripheral automation and assembly and process tools. Design for process flow. It really comes down to that. And that's why simulation is so important. Tack time, throughput is really important. Provide flexibility and a plan for future growth. That's one of the things we harp on. Our little brand tagline is evolution, right? Your factory is constantly evolving. We want to design a conveyor system that evolves with your needs, and insist on real-time data. You really need the acquisition of data to provide your smart factory, your Industry 4.0 compliant factory. Real-time data is what gives you the information and knowledge to control your process. And we also think that low voltage ASI control system technology, Matt touched on it, plug and play type sensors and applications, minimizes your installation cost, minimizes your maintenance cost, and makes the system more flexible. Next slide, please. So some of those, in addition, best practice in control technology. You want a GUI interface. You want to see real time what's happening in the factory. I was recently at one of our installations, and the control technology that we provided was a very large, very complicated system, but you could see what was happening at all times. It gave you part present proxies, rotation confirmation, trouble codes. You were able to identify where things were happening and when they were happening so that your technicians can support that. And we also provide sensors for harsh manufacturing environments, all the way down to explosion proof in some cases. We also have stainless steel chains, stainless steel tracks, stainless steel carriers for food applications and for clean applications. They also, or highly corrosive applications, they also last the longest. And again, insist on easy installation, operation, and maintenance. And of course, safety, make sure you've got all of the safety requirements covered. Next slide. So takeaways: start small, plan to scale up, go all the way to full process automation. Partner for success, pick an experienced partner. Pick a good first project to start with. If you're a small company, think about robotics as a service. That we also offer financing on our projects, so you can defer the CapEx cost and spread it over time, and set realistic expectations. Make sure you understand the real return on your investment. And again, real-time data acquisition is imperative. Next slide. So we'll open it up to questions at 50 minutes on the dot.
Excellent. That was really a great presentation. So if you have a question, you can unmute yourself and ask that question, or you can put it into the chat and I will read it for you. I learned so much. Thank you. You hear the word automation? I had no idea what it really meant. Now I know.
Well, we want to thank everybody for attending. We've done lots of Zoom meetings. We've done lots of demonstrations, but this is our first webinar, so we'd be interested in anybody's feedback. I hope it was valuable. Thank you to Matt and Bob. I looked the wrong ways. Matt, I did it again. Bob and Matt for presenting today. And if you have any questions later, just send them to Rita and we'll try to get back to you. We're located right here in Aurora, outside of Chicago. We have lots of customers in the Chicago area.
We might have a question.
Oh,
We've got, actually, I think Bob Happ, looks like you've been patiently waiting, so why don't you kick in?
Thank you, Rita, and Richards-Wilcox team. That was an outstanding presentation, and you've got some good feedback in the chat as well. Rita's going to share it with you. But I wanted to note that you do a good job of presenting a return on investment. That's part of the education for the client at the front end. How do you actually get that into the front end of your presentations when you go into a place to talk about the return on the investment and actually show them that they can get one?
I'll let Matt handle that.
Well, we get that question asked a lot. We've never done a full return on investment strategy for a customer because we rely on their management team to put that all together. We can only help them with that. We can tell them how many parts are going to get per hour, how many people are going to need, you're going to need to run this system. They can do the entry of the labor, the hours. We can also tell them approximate spare parts required each year, potential expected downtime. Some of these more complicated systems, they don't run at 100%. They run in the high 90s, like 98, 99%. So a 2% loss can, we can plan for that. And we will help with the ROI, but we can't truly put together the entire ROI.
And again, I think that starts with the customer understanding the process and the problem they're trying to solve, right? And then, as Matt just said, we can help with that analysis, but it comes down to what problem they're trying to solve, what their current state is, and what the future state will be.
Thank you very much.
Thank you.
All right, I don't know how much. Well, Frank Hudetz, I'm not quite sure where the beginning of the question is, but I see that, are you asked to incorporate AI into your service? That part I see.
Yeah, so, for us, AI is relatively new. We are integrating AI into our internal processes and as well as into our products, but we don't have a current AI implementation. But I do see the ability to use AI to optimize process flow, to optimize for predictive and preventive maintenance. And we'll do that on a case-by-case basis. That's a great question. It is a future initiative of ours. I don't have a current example I can show you.
Yeah.
I figured out the beginning of his question. How much is the service? So is there a range you can offer this group? Like, so far you have done this as the lowest part of the range of automation to this. There's so much customization.
Yeah, it really runs the gamut. You're probably looking at $30,000 for a simple push system, depending on the size of it, up into the millions and millions of dollars. Right.
Mm-hmm.
All right.
Hey, Matt, this is Dan. Hey, got a question for you.
Oh,
so we talk about preventative maintenance a lot when we're out, kind of to Bob's point. I think he was, kind of maybe going for the documented cost savings aspect, but I'm going to approach it a little differently with the preventative maintenance side of things. Have we looked at, there's some technology out there with, motors and gearboxes and conveyor chains and stuff like that, being able to put an RFID tag or some way for us to be able to proactively say, hey, this system has been running, so many hours a week. And therefore we could calculate that out to say, hey, the chain needs to be replaced, and try to get ahead of some of that. Like when we're manufacturing specifically like a new system and we're shipping it out, is there ways that we're looking at any of that type of technology?
yeah, there is. And it's, you kind of implied, it's a case-by-case basis based on speed and number of turns, whether there's an oven or heat or washer in the system, etc. But we can do that on a case-by-case basis based on the system. And that's a good point, Dan, especially for their maintenance or our team out there that's calling on these customers to say, you know what, I should call on them,
Yeah.
6 months from now, because their first chain needs to be looked at because it's going through a washer and dryer, and make sure it's, doing well. And then while I'm there, I'll check the rest of them.
Yeah, and I think, so every system comes with a operator's manual and a maintenance manual. And one of the things, Matt just mentioned the chain, you routinely measure the stretch in a chain, and that stretch is driven by, again, the speed of the chain, the weight of the material you're moving, the number of turns. And so we can predict the useful life of that chain and when you think you need to replace it. But by periodic measurement, you can get better predictive data because you'll see the stretch in real time. And similarly, you asked about the drives and the motors. Most, if not all of our drives are VFD drives on the motors. And so you can monitor, if you get data off of the controllers, you'll be able to monitor the VFD drive and see current load and frequency variation. And that'll help predict motor wear and potential motor failure so that you can get ahead of anything and not have downtime, but not have unplanned downtime, but have planned downtime.
Yeah, for our audience out there, the most common replacement parts are the chain and the trolleys and the bearings in the system, the track, and a lot of the hard physical fabricated components. They can go 50 years, or a long time. But so the maintenance is kind of key on those wear items, of course.
All
Great
right,
question.
great. Well, we're just at 1 minute left. I just want to take the time to say perfect. Thank you. Tech guy did an awesome job. Usually videos do not go well, so that was fabulous. And again, for everybody on today, I will share the presentation. I will share the recording so you can have the refresher if you want to rewatch it. And then we will share some contact information as well for Richards-Wilcox Conveyor, so you can reach out directly.
Perfect.
Again, thank you for joining us today, and I hope everybody enjoys the rest of their day.
Thanks, everyone.
Thank you.
Thank you.
Thank you very much. Thank you.